Hey, how's it going? My name is Francois Englert, and I am a Belgian theoretical physicist, and I won the 2013 Nobel Prize in Physics. Shared with Peter Higgs, my vision was to understand the origin of mass of subatomic particles, based off of a theory that him and I proposed independently in 1964. We were trying to find the experimental detection of the Higgs boson using the Large Hadron Collider, which to this day pushes protons or ions near the speed of light. The Large Hadron Collider has the capability to whip protons around the tunnel at about 11,000 times each second. Mind you, this is a $10 billion facility. Inside the LHC, two particle beams near this speed are made to collide. The LHC consists of 9,593 magnets, which are chilled to 1.9 Kelvin using liquid helium. After years of testing and upgrades to the LHC, the Higgs boson was discovered in the 125 giga-electron volt range in 2012. This experiment occurred at CERN, which is located in Geneva, Switzerland. Around this time, Obama was beginning his second term, first non-European pope was put into power, nuclear warfare threats from North Korea were heard around the world, 1,429 people were killed in Syria by the chemical warfare. The Boston Marathon bombing happened that year, and the Typhoon Haiyan hit the Philippines. Even the Snowden leaks happened that year. It was very eventful. Some people would argue that there are more important things in science, like global issues. But science contributes a lot to humanity. A large amount of innovations that are available publicly were first derived from NASA for the use in the International Space Station and through research. The scientific community has always been neutral with global issues, besides our current COVID-19 issue. Atlas Collaboration was involved also in this project, which comprises of 3,000 scientific authors from 181 institutions from around the world. 1,200 doctoral students were involved in detector development, data collection, and analysis. My role in the project, along with Peter Higgs and Robert Brout, we proposed the Brout-Englert-Higgs mechanism, which gives a mass to the W and Z bosons when they interact with an invisible field, which is called the Higgs field. This also brings about the concept of symmetry breaking, or hidden symmetry. This structure ensures that the theory remains predictive at a very high energy. Particles that carry weak interaction would acquire masses through their interaction with the Higgs field. The photon, which carries the electromagnetic interaction, would remain massless. The impact on the community with this project was that the Higgs boson was the last piece of the jigsaw puzzle that enabled physicists to explain the mass of particles, adding to the standard model that is now highly successful theory in physics. However, it adds more mysteries to solve for the standard model and implies that there may be structures at unexplored energies that we do not quite see yet. It fuels the fire for the passionate physics community. At the time of unveiling the data, CERN was packed with physicists from all over the world. What will the Higgs boson revolutionize? It will change the way we think about dark matter and dark energy. It is believed in 2021 that CERN will be on the lookout for these elusive, slow decaying particles. It could be possible that the Higgs boson is coupled to these dark particles. It also explains the generation mechanism of the property of mass for gauge bosons. It is also a possibility that more research into this particle could unveil the mass of the ghostly neutrino, which are incredibly difficult to detect with the current detectors that we have. However, they are the most abundant in the universe. They have very little interactions with matter and hold the ability to fly straight through the Earth, and billions of them fly through the Earth every day. The discovery of the Higgs field even shows the possibility that all particles are just local vibrations in their fields. The difference from the Higgs field is that it is scalar and it has no specific direction.